All right. Here we're going to use our first example, Blue Ridge Hard Taps example, to illustrate how to solve a linear program model in Excel using something we call solver. Okay, first of all, let's refresh our memory on the example. And x1 is the number of aqua spas we're going to make, and x2 is the number of hydrolaxes we are going to make. Okay, first of all is the objective function, and we're trying to maximize 350x1 plus 300x2, which is our profit. This original example has three constraints: pump constraint, labor constraint, and tubing constraint. To better illustrate how solver works, let's add two more constraints. Let's say the company is required to make at least 50 aquaspars and 50 hydrolaxes. As a result, we see two more constraints over here. Constraint 4 is x1 greater than or equal to 50, and constraint 5 is x2 greater than or equal to 50. All right, next let's see how solver works in Excel. And this is empty Excel worksheet. Before we can use solver, we have to install it. It's an add-in that comes with Microsoft Excel, but it is not installed by default. So let me show you how to install it first. This is 2007 version of Excel. First of all, let's click upper left corner, and you're going to see a window like this. Go look for Excel options, click it, and you're going to see a pop-up window looking like this. Under Excel options, we are looking for add-ins right here. Okay, and once we double click add-ins, you're going to get a whole list of add-ins that come with Excel. Okay, the one we are going to use is solver add-in. On my computer, it's the third choice. Okay, solver add-in. Let me highlight it and then click go. Okay, we got a new pop-up window called add-ins, and over here I would recommend that you choose Analysis Toolpak, Analysis Toolpak VBA, and Solver Add-in. Right now we're going to use Solver only, but later on in Chapter 9 we're going to use Regression Analysis, which comes with Analysis Toolpak. So right now let me check all of those three and click OK. All right. Now, once you do that, you can click Data over here. Under Data, you are going to see two things listed under Analysis. One is Data Analysis, which we're going to use for Chapter 9, Regression Analysis. The one we're going to use in this Chapter 3 is Solver. Okay. All right. Now we're ready to solve our hard tap model in Excel. Okay, this is empty Excel worksheet. It's going to be a good idea for you to name those variables clearly, so you're not going to get confused later on. Okay, let's say we're going to keep our decision variables x1 and x2 in cell C6 and D6. Actually, it doesn't really matter where you want to keep them. To do that, we're going to name each of those two variables first. X1 is, okay, aqua spar. X2 is hydrolux. And, but keep in mind, X1 is the number of aqua spars to make. So we call that number to make. All right. So our X1 will be in cell C6. Our X2 will be in cell D6. Next, we are going to type coefficient. And in this case, coefficient is the unit profit. All right, to make it look clearer, I'm gonna drag it over here. Okay, so the coefficient of x1 in objective function is $350, and coefficient of x2 is $300. Okay, let me make them in the middle of the cell by doing this. All right, now we are ready to prepare our objective function, which is profit. All right. Profit is given by 350x1 plus 300x2. So let's see how it works in Excel. It's going to be a formula in Excel. Formula in Excel always starts with, okay, an equal sign. It's going to be equal to, okay, 350x1. 350 is in cell C7. So I'm just going to click it and highlight it, times, which is star in Excel, times what? X1. X1 is in cell C6. Okay. And then plus 300, which is in D7, times X2, which is in cell D6. And that is our objective function. Then we're ready. You click enter or return. So here we go. Right now the profit is 0 because cell C6 and D6 are empty. That means, well, they are 0 right now. For instance, you want to change x1, x2, you may simply do that. Okay, let's say x1 is 100, x2 is 100. You see, the profit is changing accordingly. According to what? According to the number of aqua spars and number of hydroluxes we're going to make. All right, next we are gonna prepare constraints. Okay, so let's do this. Okay, constraints. Keep in mind we have 5 constraints, not including non-negative constraints. Okay, so first one is about pump. Second one is regarding to labor. Constraint 3 is about raw material tubing, and then aquaspar requirement and hydrolux requirement. All right. And first of all, let's see how many pumps we're going to use. Keep in mind, each aquaspar needs 1 pump, so does each hydrolux. So the coefficients are 1 and 1 respectively. Okay, so once again, let me move them to the middle of the cell. Okay, all right, here's the well, you may say tricky part. So how many pumps we're going to use? Okay, it's equal to 1x1 plus 1x2, right? So in cell E10, we're going to type the formula. Okay, the number of pumps we're going to use is going to be equal to x1 times, 1 times x1 plus 1 times x2. Here we go. All right. In F column, I'm going to do something slightly different from what you will see in the textbook. I'm going to put the type of the constraints over here. So for constraint 1, 2, and 3, they are of the same type, less than or equal to. Okay. For constraint 4 and 5, they are greater than or equal to type. And in G column, we are going to put in the information regarding the resource availability or constraint. Okay, so how many pumps do we have available? 200, that's easy. How many hours of labor we have? 1566. How many feet of tubing we have? 2880. And we are required to make at least 50 aquaspars and 50 hydroluxes. Okay, so those are the main constraints over here. And next, we are gonna figure out how many hours of labor we're gonna use. And once again, we're gonna type the coefficients first. 9 hours per aquaspar, 6 hours per hydrolux. Okay, and then we're gonna type a formula in cell E11, which represents the total hours of labor we're gonna use. It's gonna be equal to what? 9x1 plus 6x2, right? So here we go. 9, which is C11, times x1, which is C6, plus 6x2. 6 is in cell D11, times x2, which is in cell D6. Return. Here we go. All right. And next, I'm going to show you a trick we can use in Excel. Okay, but before we do that, let's put in all the coefficients in the constraints first. Okay, keep in mind in constraint 4, aquaspar requirement, we're going to make at least 50 aquaspars. So the coefficient of x2 is 0 because it has nothing to do with hydrolux. All right, so in cell E12, we're going to need what? We're going to need the total feet of tubing we're going to use, okay? And in cell E13, it's the total number of aquaspars we're going to make. And when we were working on the number of pumps we're going to use and the number of labor hours we're going to use, did you see something we have in common? For example, in cell E10, the formula is what? C10 times C6 plus D10 times D6. And once you highlight cell E11, the formula is what? C11 times C6 plus D11 times D6. Okay, in both cases, we keep referring back to what? X1 and X2, they are in cell C6 and D6. The trick I'm going to teach over here is called absolute cell reference. Because it doesn't matter which constraint we're talking about, we're always going to refer back to X1 and X2. So here's what I'm going to do. Here's how absolute cell reference works. Because we are going to, well, fix cell C6 and cell D6. A trick I can teach you is that you simply click F4. You see, two dollar signs are added. One in front of C, the other in front of 6. The $2 signs do one thing. Nothing but absolute cell reference, okay? And we're going to do the same thing about D6. You can move your cursor either in between D and 6 or at the end of it, doesn't really matter. And you click F4. See, $2 signs are added automatically. And you click return. So next, we are going to copy the formula in cell E11 all the way down to E12, 13, and 14. And you move the cursor to the lower right corner and click it and drag it down. Here we go. See, you highlight cell E12. See the formula? C12 times C6 plus D12 times D6. That is exactly what we want, which is 12x1 plus 16x2. And if you look at the cell E13 and E14, we see the same thing. C6 and D6 are fixed. And that's what we mean by absolute cell reference. All right. Right now, we are ready to solve it. And to do that, click Data and look for Solver, click it and launch it. Okay, once you launch Solver, you are going to see this pop-up window called Solver Parameters. First thing you need to take up is called Set Target Cell. It's nothing but our objective function. In our case, profit function. Our profit is in cell E7. So how we're going to set our target cell? Well, simply highlight it. See, it changes to E7, which is exactly where the total profit is. Okay, next, we're going to make a choice. So in our case, it's a maximization problem. So we're going to highlight and choose MAX. Okay. In some other examples, we might use MIA or other choices. Next thing we need to do over here is by changing cells, they are nothing but our decision variables. Okay. So a better way to do that is, okay, you click this by changing cells and you highlight our decision variables. They are x1 and x2, right? And in Excel, they are in cell C6 and D6. So you're going to highlight both cells. Here we go. You see, from C6 to D6, that's where our decision variables are. All right, now we're ready to add constraints. Here's why I add 2 more constraints. Okay, at least 50 aqua spars and at least 50 hydrolux must be made, because I want to show you how to add different types of constraints. A trick over here is that you want to group the constraints of the same type all together. For example, in our case, constraint 1, 2, and 3 are of the same type. They are less than or equal to type. Constraint 4 and 5 are of the same type. They are greater than or equal to type. So when we are trying to add a constraint, we're going to add each type at a time. How are we going to do that? Let's see. Click Add. We're going to get a new pop-up window called Add Constraint. Okay. In cell reference, we're going to highlight and select the number of units of resources we're going to use. In our case, it's going to be cell E10, E11, and E12. All right. And next, what type of constraints we are talking about? Less than or equal to, which is the default value over here. So we don't have to do anything. And when you click this, you're going to see there are different options. Next one, we're going to choose what? Greater than or equal to. All right. Constraint is the resource availability. In our case, they are in cell G10, G11, and G12. You highlight and select those 3 cells. Here we go. Basically, what do we do just now means what? It means number of pumps we are going to use is going to be no more than 200. Number of hours of labor we're going to use is no more than 1,566, and so on and so forth. Okay, so we add the first type of constraint already, but we have another one to go, greater than or equal to type. So we're going to click Add. Otherwise, we're going to click OK. So let's click Add. So we get a brand new Add Constraint pop-up window. So this time, cell reference is how many aqua spars we're going to make and how many hydroluxes we're going to make. They are in cell E13 and E14. Highlight those 2, but this time be careful. They are greater than or equal to type constraint. So let's choose greater than or equal to. And the minimum requirement is what? 50 a piece, right? So constraints are 50 and 50. They are in cell G13 and G14. All right. Now that's all the constraints we have. And right now we're going to click OK. But you may say, okay, what about the non-negative constraints? There's a better way to take care of those non-negative constraints, which I'm going to show you in just a moment. So right now, let's click OK. So we go back to the original solver parameters pop-up window. Before we solve it, there's one more thing we're going to do. Click Options right here. And in this solver options window, I want you to pay attention to two things only. First of all, right here, assume linear model or not. Well, we're talking about the linear programming. Of course, it's linear model. So let's check assume linear model. Okay, next thing I want you to look at is assume non-negative, okay, which is indeed true. So we're going to assume non-negative. That's why originally in Excel worksheet, we do not type the formulas for non-negative constraints because they can be taken care of right here. So we check both boxes and do not worry about all the other options or choices, and we are good to go. So click OK and solve. Here we go. You see, our optimal solution is what? 122 aqua spar and 78 hydrolaxes. As a result, our optimal profit $66,100. And when we look at all those constraints, what do we see? We used all the pumps we have, and we used all the labor hours we have. But we have some tubing left, and our optimal solution automatically satisfies the two minimum requirement, making at least 50 aqua spars and 50 hydrolaxes. All right. Let's keep the solver solution and click OK. You may say, okay, what about those reports, answer sensitivity and limits report? They are materials from chapter 4, which we are going to skip. So let's click OK, and we're done. All right. So this is the Blue Ridge hot tub example, and we use this one to illustrate how to solve a linear programming model in Excel using an add-in we call solver.